Okay, well, happy Monday, and thank you for coming and attending. Today, we are continuing on talking about data wrangling, and so we've been kind of working with dplyr. We've introduced a little bit of dplyr, and you've used a little bit already, just in terms of like using filter and select, and that's been about it so far. I think maybe mutate, filter, and mutate. Maybe arrange, resorting some of those things, and I hope you're starting to feel comfortable using that. And don't worry, I'm going to give you some homework where you have to become comfortable with it. And today we will be looking at these very two powerful. Well, okay, there's group by, and then there's summarize, and they're separate verbs, but they work very well together. Okay? Now, so Hadley, the author of these packages, and truly, kind of a father of the tidyverse. He's from New Zealand. They spell summarize with an S. Later on, he added a function called summarize with a Z. Same functionality, same exact thing. They're aliases for each other. But I'm kind of accustomed to using the original function, so I will continue spelling it the non-American way with an S. Okay? And basically, a summary function, its whole purpose is to summarize a bunch of values with one value, right? And so we're very familiar with the idea of a summary by taking a set of numbers and calculating the mean, right? And if you think about it, whenever you do a summary function, a summary statistic, it just reduces, you could have 100 numbers, you can have 5 numbers, you can have 1,000 numbers, and it just reduces it to 1, right? And we're all familiar with a bunch of kind of summary things in our life. So we have the mean, we have the median, we have the standard deviation and the variance. And are you guys, well, we never, I guess this is your intro stats class, so we never like formally talked about like what the variance is. Is anyone comfortable giving a definition of the variance? Yeah.
Standard deviation squared.
Okay, square the standard deviation. Okay, so what's the standard deviation then?
Standard deviation it's a number, and the way you interpret it is that this is the number by which every point in the data set, it typically varies from the mean by this number.
Okay, that's a good definition. Yeah.
Yeah, not the way I calculated it. Forgive me if I'm mistaken. It's the difference from each point to the mean, and you square that, I think.
Yeah, the variance is the average of the squared distances from the mean. So if everything's very close to the mean, right? You have a whole bunch of values. Like if the mean is 5, and all of your values are like 6 and 4 and 5 and things like that. Everything's very close to the mean. You take what's the differences from the mean, distances from the mean. It's like 1, 0, 1, stuff like that. You square all of those distances and you take the average. That's going to be your variance. If the average is 5 and you got values like 0 to 10 and stuff like that, then distances from the mean are like 5 or -5 or things like that, and you're going to have more variance, more. So you take the average of the squared distances from the mean. Okay, standard deviation is the square root of that, so it puts it in the same units, because if you're talking about centimeters, variance will be in centimeters squared, square centimeters, which is okay. But then if you're talking about dollars, then your variance is in square dollars, and I don't know what that is, okay? But it's technically what it is, right? Square distance, square dollars, things like that. So anyway, that's but basically it just takes a thing. It measures basically how spread out your numbers are. Are they all very similar to each other? Are they all spread out? Variance measures that, standard deviation measures that. Other summary functions that you guys are familiar with, your GPA, right? You've taken a whole bunch of classes. We boil it down to one number, and they say, oh, this is the one number, and I don't know, is it super important or not, or I don't know, right? It's only like, once you're here, the importance is much less, my opinion, but I'm also on the opposite side where now my GPA matters nothing. So or I don't know. The other summary function I like to think of is like movie ratings with like the Rotten Tomatoes score. It takes a whole bunch of individual movie reviews and then it summarizes it down to a single number, right? And so summary functions are useful because it just gives you one number to compare rather than like having to keep track of a whole bunch of things in your head, right? But by nature, they are reductive. Okay, so let's take a look. We're gonna look at this Gapminder data. Maybe I'll move my face over here. And so if we've been working a little bit with the Gapminder data, and basically the full data set is pretty big, 1,700 rows. We've got a bunch of countries. It tells you which continent they're in. And we've measured 3 numeric variables at different points in time. So in 1952, what was the life expectancy? What was the population? And what was the GDP per capita? Sometimes you see these life expectancy numbers, 28.8, and you go, wow, that's really low, right? A part of the reason why the life expectancy is so low in some places is because of high child mortality, okay? So it's not that like once you hit 28.8, it's like you're expected to die or something like that, okay? Of course, it's like there are gonna be old people and seniors and things like that. It's just if out of 100 people that were born, if a large portion of those children died in infancy, age 0, age 1, things like that, then the average is going to become dramatically lower, right? And so when you see things like life expectancy being this, very low number, a lot of it is due to child mortality. And so when countries gain access to, medical care and medical access and, things like that dramatically increase, I guess dramatically reduce child mortality, then you'll see a huge bump in life expectancy.
Could it also be like war or conflict?
Yeah, certainly that plays also a role. Okay, so violent conflict will also reduce life expectancy, but I would say probably the largest single contributor to low life expectancy would be child mortality rates. Okay, so anyway, there's a whole bunch of different countries. I don't know how many continents. 6 continents represented in the data set, or something like that. Okay. Yeah. Another question.
Should we care about the differences between a tibble and like a data frame? Or
a tibble and a data frame.
Mm-hmm.
So, okay. So a tibble is a kind of data frame. Okay.
Uh-huh.
So when you work with dplyr and things in the tidyverse, it produces tibbles. Okay. So data frames are basically these tables. Each column has, some kind of thing. And basically, the restriction for a data frame is that in a single column, it has to be the same data type. So if you have words in a column, like everything has to be treated as words. And if you have numbers, everything has to be a number. You can't mix numbers and words in a single column. But that kind of makes sense because the way we think about tables and data frames here is each column is a variable. Okay, a tibble is like it is basically a data frame with a few features added that tidyverse uses. Some of them is like a tibble is aware of how wide your screen is, and so it only tries to fit what can fit on your screen. Okay, so a tibble is whereas if you have a data frame and it has like 50 columns, and you just say print the data frame, it's going to try to print all 50 columns. Whereas if it was a tibble version of the same data frame, 50 columns wide, and you say print the tibble, it's going to say, well, how many columns can fit on my screen? Oh, 13 columns can fit. I'm only going to print 13 columns, and then I'm going to write a note that there's an additional 37 columns or something like that.
Right.
Okay.
So you're saying in the same column, for example, country, you could have like integers in Afghanistan. You can mix.
No. In a data frame, each column has to be a single
Right.
variable. You cannot mix. You cannot mix.
But Tibble, you can.
No.
Oh, okay.
Tibbles and data frames, you cannot mix
Okay. Okay.
things. Okay. So basically, a tibble and a data frame are the same.
Mhm.
It's just tibbles
More features.
have a few more features that just make your life a little bit easier to work with when you're working in
Convenient.
R. It's
Okay.
so it doesn't blow out your screen when you say show me the thing and stuff like that.
Thank you.
Question?
I was just gonna clarify. It's probably like a subclass, right? The tibbles.
Yeah, if you're thinking of in terms of its object hierarchy, so tibbles inherit from data frames, if that's what you're thinking. Yeah. Okay. Okay, so the summary function basically says, okay, well, we've got 1,700 rows here, right? 1,704 rows, and then I click summarize, and basically it reduces the entire table down to one row. And here, when you do summarize, you specify, I guess, names of the new columns that you want, and you write out the function that you're going to use to calculate these things. So for one, I said the average expectancy. And to calculate the average, I'm going to say, give me the mean. The standard deviation, I'm going to do standard deviation of life expectancy. The minimum life expectancy, the median life expectancy, I did the third quartile, which in R you find by doing quantile, and then you do probability equals 0.75. And if you wanted the first quartile, you can do quantile and then probability equal to 0.25. And basically any other percentile that you want. Usually we often think of Q1 and Q3, but if you want the 10th percentile, 90th percentile, 99th percentile, you can look at those things up, right? And then the maximum. And that's it. All of these things I put in na.rm equals true, because if you have a missing value, the mean of a bunch of numbers with a missing value is unknown, okay? So for example, if I said, and you go, well, why is it always unknown? Well, I said, okay, if I said, oh, my sister has 3 children, she doesn't, but if I said, somebody has 3 children, and the ages, one kid is age 10, and one kid is age 8, and, I forget how old the other kid is, okay? And then I say, what's the average age of the kids? You'd be like, well, if you don't know the age of this other child, you can't give me the average, right? So you can say, well, I can give you the average of the numbers you have given me, 10 and 8. The average of those is 9, but that's not going to be the average age of all 3 children, right? So if you have a missing value, the average, the mean, or the any other summary value is going to be unknown. So you have to explicitly tell R, if I'm missing a value, treat it as if it doesn't exist. And then it'll be like, oh, you have 3 kids, but you only know 2 of them? Well, I'll just give you the average of the 2 you do know. And that's basically what we're saying here. na.rm is remove anything that's missing equals true. And this is how.
Is there a function where you could set it so that it automatically removes values that are too crazy? Like, for example, a kid is like 1,000 years old.
No, there's no function that says too crazy, because R has no idea. Okay, you can specify. You can say, all right, well, if it's ages, if anything's over 120, let's throw it away, right? Because we're gonna say, in modern times, we don't know anybody, right? So yeah. Do you have a question? No.
I was saying, when you were saying, I was like, could you filter it out? Like,
Yeah. But you have to specify these things, right? You can't just say like, all right, computer, go.
There's no AI.
Yeah. No, I mean, not right now. I mean, certainly you can write a function that says, oh, okay, you know what, let's figure out the, from the 92nd to the 98th percentile, and then we're going to just throw away the top 2 and bottom 2 percentile, which, I wouldn't say that's too crazy. Maybe the top 1/10 of 1% and the bottom 1/10 of 1%, but everybody's going to have different thresholds for what is highly unusual. And then if we're talking about highly skewed distributions, then everything kind of changes as well. So anyway, all to say, this is what it outputs, right? So this summary, this average, is the mean of all 1,704 values, okay? And so this is the average life expectancy across all years, across all countries, right? So we're just taking this entire column, 1,704, and we're just taking the average. Does that make sense? I don't know, right? So you have to think about like, well, what makes sense to calculate for an average? And I would say maybe life expectancy mean works. Okay, if we're talking about population, I don't know if the mean would make sense, because like if we're talking about, you know, Canada, United States, and Mexico, like, does it make sense to talk about like what's the average population of these countries? Like, I don't know. Like, you'd be like, okay, but why would we, you know, why are we calculating? Like, is that useful? Maybe it'd be more useful to calculate the sum, right? And you say, okay, the entire population of all of, you know, these Northern America countries. So I don't know, but anyway, this is summarized. It takes all the rows and it just boils it down to one. Now you can say, well, you know what? Let's only do it for Americas in the year 2007. So if we say in the year 2007, I think that's the most recent year in the data frame, and we can say continent Americas, and we could just say, and this is the raw data. So we have Argentina, Bolivia, Brazil, Canada, Chile, so on and so forth. We have a total of 25 countries represented, okay? And that's what we have. And now we can just say, all right, well, for this, let's calculate the average life expectancy. And so in 2007, the average life expectancy across the Americas was 73.6. The minimum was 60.9. The maximum was 80.7. Okay, Canada with the max at 80.7, and I think Haiti with the minimum at 60.9. The median being 72.9, and the average being 73.6. Okay, and we can see, you know, a count tells you how many were summarized. 25 values being summarized here. And again, these are the formulas here. If I take the filter and I go from 2007 and I just say, okay, well, let's look at 2002. How much has changed? And we could say, oh yeah, you know what? In 2002, average life expectancy was 72.4. 2007, it went up to 73.6. Median life expectancy in 2002 was 72.0. And in 2007, the median is now 72.9, so on and so forth, okay? So, so you can kind of do this. And you say, well, you know what? What if we take the same concept, and what if I wanted to do it across all of the different years, right? So we had, you know, from 2007, 2002, so I calculated, you know, the average for all of the countries in the Americas, and in 07 and 02, and what if I go back to 1952? Can we do that? Sure, we can, okay? So what I'm gonna do here is I'm gonna do a Gapminder. I'm gonna filter just to the Americas, and here I'm gonna say group by year. And when you do group by year, at first it doesn't look like it has done anything, because here it leaves all of the individual rows. The individual rows would be Argentina 1952, Argentina 1957, and so on and so forth. The only thing that you'll notice that's a little bit different is it says groups, and it says year 12, and it says there's 12 groups here. Okay, because there's 12 different years represented, 1952, 1957, up to 2007. We have 12 different years being represented, and so we've established 12 different groups. And so now I'm going to take this group by function, and I'm going to pair it with summarize. So if you look at this code here, it's exactly the same as basically this code, except I've replaced the filter, sorry. I'm going to, okay. So here I have filter year equals 2002. Now over here I just have filter continent, but I've added this line group by, okay? So I've filtered it only to countries in the Americas, and then I'm gonna group by the year, and then I say calculate all of these things. And so it calculates, in 2007, the average was 73.6. In 2002, the average was 72.4. In 1997, it was 71.2, and so on and so forth. And we can see each of these things each summarize 25 different countries. And so we are calculating the values for basically each of these summary values for the 25. Okay, so this top row, 73.6, 60.9, 71.8, will match what we have here, 73.6, 60.9, 71.8. So it's basically, so here I filtered to year 2007 continent Americas, and I'm getting basically the same thing right here. And then I did the same thing, but I filtered to year 2002, and I'm basically getting this row here. And this would match if I filtered to year 1997. But the nice thing about this is I don't have to do each of those groups individually, all right? I don't have to filter to year 2007, filter to year 2002, filter to year 1997. I could just do it in one action, and I say group by the year, and then it's going to, dplyr or the tidyverse will basically filter down to each year, or whatever you grouped by here, and then for each of those kind of subgroups, it's going to calculate all of your summary statistics here, which is super handy. Okay, so it only prints the top 5 rows, but there's 12, and it goes all the way down to 1952 because I've arranged these in descending order by year. Yeah, question.
So how would we be able to see all of them? They're all printed out online?
They're all printed out. Right now it just doesn't fit on my slide, but if you ran this in R, and again I uploaded the RMD file, so if you wanted to run it in R, it will appear there. Okay, so I've taken this, and so here's the beautiful thing about pipes, right? So one thing is I could save this table, right? I could just, in front of this whole thing, I put a little arrow, and I say store this table somewhere. I could call this like life expectancy for the Americas or something, and it would store this 12 by 8 table, which could be handy, and we might want to use that later. But another thing is I could just pipe it, okay? I can just pipe it. So here, let's see if we can start reading this, okay? So we start with the Gapminder data. We're filtering it to continent Americas. I'm going to group by the year, and then I'm going to run the summary function. And this time I'm only basically calculating the mean life expectancy. Okay, I also counted the count, but that's actually not necessary, right? So basically, if I do this, if I stopped here and I printed out what I would have would basically be this table, but with just 3 columns. I would have the year column, because I'm grouping by the year. I would have the average expectancy column. I wouldn't have any of these minimum, Q1 median, Q3 max, and the count. Okay, so I would only have 3 columns: the count, the average, and the year, right? Based on this command here, where I'm doing summary, average expectancy, and count. Yeah.
Could you explain what group by does? It just puts them.
It signals to R that when you calculate summary, don't do it for the whole group, right? So the entire table has like 3. So after I filtered, so the entire table has 1,704 rows. After I filter to the Americas, it has 300 rows. Yeah. And if I just did summary on that, it would just calculate the average for all 300. Okay? But here I'm saying establish groups based on the year, right? And so it's going to say, oh, I've got 12 unique years represented: 1952, 1957, 1962, so on and so forth. And so it's going to say, all right, for each year, we are going to calculate the average. And so rather than calculating one row, which is, well, here I filtered to the year, but so if I did it, we would get something that looks like this if I didn't do group by, except the count would be 300. Yeah. Right? And here I'm saying basically establish groups where you're basically filtering to each year, each unique year, and it calculating the average. And then it's kind of
It'll give you 12 rows.
Yeah, it's giving me 12 rows. Okay.
So 12 unique years.
Yeah, 12 unique years. This is what we call the split, apply, combine. So it splits the data from 300 rows into 12 groups of 25, and then it applies those summary functions to each of those 12 groups, and then it combines them back into one table.
Done.
Yeah.
For like the group by function, it's basically for like each of the values for a given variable. Right?
Yes, so you only want to use group by for a categorical variable or something that can be made into a categorical variable. So like if, I think if it's numeric, it's going to try to do it for each unique numeric value. So if it's like, integers, sure, it could kind of work, but if it's like a continuous numeric variable, it's not a good idea. I think I don't know what will happen. It might complain or it might try to do it anyway. Yeah.
Would you be able to do some sort of histogram where you kind of group by like ranges? Maybe you could use the ranges to.
So you would have to. There is a function called what is it? In Python, it's called cut, and here I think it's called Untile. Okay, and so in R I think there's a function called Untile, and you can establish basically bins, and you can do like Untile 4, and it will take your data, and it'll take a numeric variable. And then it will split it into the top 25%, next 25%, next 25%, bottom 25%. Okay, and that will become your categorical variable, and then you can apply a group by on that. All right, and I think, and it doesn't have to be Untile 4. You could have Untile 10 or something like that, and you could kind of split it up by that. Or if you really wanted to, if you've got something like income or something, you could do, Untile. And I think you can give it a vector, and you can be like, the top 0.1% and the top 1% and the top, 5%, top 20%, and compared to like the bottom 60% and stuff like that. And you can do those kinds of operations as well, but you have to establish those groups if they're not already there. Okay, does that kind of make sense as far as the filter and the group by and the summarize?
Why do you need another pipe by count? Another pipe symbol.
So I'm taking the output of that. Okay, the output of this is basically, imagine this table with 12 rows, but now only 3 columns, year, average, and count. And really, I could have just gotten away with year and average. Okay, and I'm going to take that table and I say I want to make a plot based on that table. And that plot, so I'm going to pipe this straight into ggplot. And using this basically as my data table in ggplot, I'm going to say let's put a year on the x-axis, average expectancy on the y-axis. Let's add a line. Let's add points and theme line draw. And this is my plot, and it shows how average life expectancy in the Americas has changed from 1952 to 2007. Okay, and what we see is there's been kind of almost a purely linear, almost straight linear increase over time. As every 5 years that have gone by, the average life expectancy has gone up, maybe about 4 years or so. Okay, which is
if you didn't add the pipe symbol next to the count, would it just load the group by year? You go back to the previous slide. If you didn't add it by the count, would it just automatically leak the group by year data into the ggplot?
No, it would just stop here. Without the pipe, it would just produce, if you didn't have a pipe, it would just produce this table. Okay? And you can do the same thing, but you could take this, you could put a little arrow at the front here and store the table somewhere. And then you could do ggplot with, that table that you've stored and created this. All right? So that, that's one way to go about it. But you can also kind of, a fun thing, I don't know about fun, but just like time-saving thing is you just pipe your results straight into a plot. Yeah.
When you use a pipe and then apply all these like different verbs, if you were to go back to just like the original gapminder in the next line without the pipe, would it be the original like 1700 rows?
Yes. Okay. Yeah. Gapminder. So all of these functions, none of these affect gapminder. Okay. We're just starting off with 1700 rows. Filter it to the Americas. Group it by this thing. Summarize it. Okay. And it's not affecting any of the original data. Yeah. Okay. If you wanted to, you have to use the arrow and you assign it back. And you would assign it back to gapminder. Probably not a great idea. Whenever you want to assign something, you probably want to change it. Even something like mutate, where you're like creating a new column, it's not affecting the original data. It's creating a new column in the output, but if you want to use that thing, you have to store it somewhere. Okay, so this is kind of the picture here. Okay, so let's say, well, all right, we did the Americas, that's great, but let's look at other continents. You know what, I'm gonna forget. Let me give you your first view quiz answer, but I gotta look up the answers because I don't remember these things. All right, what is it? Week 3, Monday. Do we feel like time's going fast or slow?
Super fast.
Super fast? Slow? You guys have midterms yet?
Yeah.
This week? Next week?
Next week.
Next week, some midterms. Week 4 is like super popular midterm week. Okay. All right, your first one, week 3, Monday, the letter C. C as in cat. C as in cat. Okay. So here, I'm grouping by continent and year. So, okay, we have 5 continents and 12 years. Okay, so we have a total of 60 rows. So, so here I have Africa 1952, and there were 52 countries represented, and they all get summaries. I'm actually not sure how Gapminder works, because how does the Gapminder data work? Because let's do some investigation here. I gotta load the library. Okay, and let's do data Gapminder. Okay, and then let me ask questions about Gapminder. Excerpt of Gapminder data on life expectancy, GDP per capita, and population by country. Gapminder unfiltered. Okay, well, I have to look at Gapminder unfiltered. Because, you know, if I go to say, let's do Gapminder, I'm just curious. Filter, let's do continent equals Europe. Let's tidyverse. Okay, so we'll load the tidyverse. All right, now let's filter to this. Here, like, do they do like Czech Republic? 360 rows. All right, let's print. Let's do 100 rows. Okay, because the Czech Republic, I mean, you know, for a time it was Czechoslovakia and things like that. So I don't know how they established what, you know, like what's the history of the Czech Republic? Czechoslovakia 1918, Czech Republic 1993, and what was, so, say, you know, you had the Czech Republic and Slovakia together, and then, it, you know, it split, and so, you know, I don't know how, do we have, like, Slovakia also in here? So I don't know how this works, right? Because, no? Did I spell this wrong? Serbia. Slovak Republic. Okay. So yeah. So I don't know how this data is working, because these, you know, not every single country has existed, you know, throughout time, and you know, there's been changes, and you know, right now we have Germany, right? But then there was a time in history where there were 2 Germanys, and that's not reflected in this data. So I don't know what. So this Gapminder data, where it's like, oh, this is great, and da 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 da. But this is kind of like assuming the names that existed at this time, and these boundaries or political regions or whatever, like, existed throughout the last 60 years, which isn't true, right? And so, you know, these are questions that you got to ask. You'd be like, oh, okay, well, what was the population of Germany in 1980? and you're like, oh well, which Germany? And or like together, you know, and so I don't know, when it talks about Germany's population 1982 or something like that, what, you know, how did it figure that out? So I don't actually know, and that's why I was looking up at the help, and maybe that's where Gapminder Unfiltered comes through. So, but you know, that makes your life a lot more complicated, right? In terms of, so it's got 3,300 rows and
Domain
Huh?
knowledge.
right. This is where your domain knowledge goes and stuff, because a lot of times you're looking at historical things and you have to think, oh well, what was the world like back then? And it's not.
You spell continent.
Did I? Yeah. Continent equals
Here's this content.
continent. Yeah, thank you. Yeah, that would do it. Okay, and then so let's. Oh, it's still. I don't even know how to. So it just goes Germany. Yeah. Lies. Okay. I mean, right? I mean, where's this number coming from? And I'm surprised they can even give me numbers down to the single, the last digit. So I'm highly skeptical of this data, right? It's handy for like in-class lessons, but you're like, oh, what was the population of Germany in 1982? You know, I don't know. You know, you're telling me this number. Sounds nice. You know, okay, well, anyway, that's always be suspect of your data a little bit. It's okay to be skeptical. So that's, I guess, a little bit beside the point of what we're trying to do today. I'm not trying to like, I'm grateful for this data. It's nice to think about, but it's also, you know, like, you know, especially in Africa where like other powers have just been like, oh, you know, we're gonna cut this up and make colonies and change boundaries and rename places. You know, like the Congo used to be called, well, there's two Congos, but you got, you know, it used to be called Zaire, and, you know, all kinds of stuff. And
How do you know so much about history?
I don't know anything about history. Okay.
About Africa. The
I like
continent of
maps.
Africa.
I like maps, but yeah. All right, so here I'm going to just do group by continent and year, and so now I've got 5 different continents represented and 12 different years, and so we have 60 different kind of lines in this table. And then with this output, I can pipe it into ggplot, and what am I going to do? I'm going to put year on the x-axis. I'm going to put average expectancy on the y-axis. And then what do I want to do? I think I will do color for the continent, okay? And so this is kind of what the output looks like a little bit here. And I'm going to just, the full table looks like this, right? And so we can see, you know, this is the line that we had for the Americas, starting around, you know, 54 and ending up close to 74. And then, you know, for Asia and Europe, Oceania, I think, is just Australia and New Zealand, which, you know, there's a lot more countries in Oceania. Yeah.
What
However,
even is that?
huh?
What even is Oceania?
Oceania, that would be, according to this data set, it is Australia and New Zealand, I think. Let me see. But it should include all kind of like Pacific Island nations. I think, yeah, I think Australia, let me see. Yeah, Australia and New Zealand, but it, you know, it would also include like the Tonga and Kiribati and stuff, I don't know. But data set's limited. All right, but it, and so, you know, yeah, this. So probably if you took the average life expectancy of Oceania, in real life it would probably be lower, but you have kind of these more higher HDI places versus other places. All right. Okay, so that's what we have there. All right. So using group by and summarize along with ggplot. Yeah.
So if we wouldn't use the group by, we would just have like one.
Yeah, if we didn't do group by, it would just be one line, and it would be the average for all 1,700 countries.
Yeah.
Okay, or not 1,700 countries, 142 countries, I think. Okay, 1,700 rows divided into 12 groups based on year. But all the countries would be in one, represented with one dot. And here I'm separating them out by continent. Okay, what am I plotting here? I don't have a group by. I filtered continent to the Americas, and I'm plotting year against life expectancy, and I'm separating them by color, by country, into different colors. And this is what we have. Okay, and so it puts the countries in alphabetical order: Argentina, Bolivia, Brazil, Canada, so on and so forth. And I mean, colors look pretty, but it's also like really hard to read, right? I'm like, okay, what country is this? Something purplish. It could be any of these, right? So you really, once you get over like 6, 7 colors, like it becomes really hard to tell. So I don't know if color is the best. So there's a few things you can do to kind of help things out. But there's no group buying here, and there's no summarizing here. Okay. So this is kind of the full thing. But again, it's pretty hard to tell what's what. Here I have one thing with just kind of gapminder filtered to the Americas. Over here, I'm creating a summary table. So can we read what this says? Gapminder filter to the Americas, group by, summary, and average expectancy. So what's this going to do? How many rows and columns will this table have? Americas underscore summary.
12.
I'll have 12 rows. Yeah.
2 columns.
Yeah, well, 3 columns, 1 for the year, 1 for average expectancy, and then there's also a count here. But yeah, basically. Okay, it's basically what the table that we use to create this. It's basically this part. Okay. And I'm storing that into America's summary. Okay. All right, so look at what I've written here. This part, gapminder, filter, ggplot, geom line, geom point, theme line draw, this is the same that we have here. Okay. So basically, I'm establishing the same thing, and then what am I adding on top of it? I'm adding another line, and here I'm calling data from America's summary. So these lines up here, so you can combine, you can draw things on a single plot from different data sources. So this one's using gapminder filtered to the Americas, no grouping, nothing like that. And here I'm using a different data set, using this data America's summary, which comes from over here. Okay, so I've run this thing where I filtered to Americas and I've summarized it, and I've created my own kind of table here called America's summary, and I'm doing that. And then here within geom line, I'm providing a mapping. We're going to put X on the year on the X and average expectancy on the Y-axis. I'm going to establish a color, okay? And then line thickness 2. And so you can start to see kind of a fat line right there. And so this would be the average for everybody, So it's basically this plot, and I've averaged an average line there, or added an average line for everyone. Okay, I wanted to address this issue of like, okay, what is this color up here, and what is this color right here, and what is this color, okay? So one thing you can do is I'm going to take the countries, so I'm going to go to the last year. I'm going to say filter year equals 2007. We're going to filter it just to the Americas continent. I'm going to select just these two columns, country and life expectancy, and I'm going to sort them in descending order by life expectancy. Okay, So we could see, all right, in 2007, these were the life expectancy numbers. Canada was at the top with a life expectancy of 80.7. Then number 2, second highest life expectancy was Costa Rica, then Puerto Rico, Chile, Cuba, and the United States coming in 6th place, which I think for a lot of Americans, this might be a little bit surprising, but also maybe not also surprising to see the United States being beaten in life expectancy numbers by, by other nations, right? Because if you go back to the 1950s, life expectancy through the United States was much higher than a lot of other places, but in the last few decades, very little progress has been made in life expectancy here. Okay, so anyway, I'm going to just basically take this column, and I'm going to just take the country column. Okay, so I've taken basically the exact same line, and I use this function called pull, and basically it just extracts this country column. Okay, it extracts this country column. So I've got Canada, Costa Rica, Puerto Rico, Chile, Cuba, United States, Uruguay, Mexico, so on and so forth. And we're going to use this to establish the order. Okay, so I'm doing ggplot. X is year, Y is life expectancy, and then for color, I should probably split this in 2 lines. I'm going to take country. I'm going to make a factor out of the country, and the levels will be in this order, in the country order, right? And so now my plot, it's a little bit harder to see, okay? But now the colors are arranged in the order that they appear in 2007, kind of in rainbow order here. And so the countries are now listed, rather than like over here where you have to try to guess which country is which color over here. Now you can say, okay, the very top line belongs to Canada. The second line here, which it's a little bit harder to read, will be Costa Rica. And you can see how Costa Rica has made, so, the order of colors is not the same over here in 1952 as it is over here, right? So, the United States is in 6th place in 2007, in 1952 is in 2nd place, but, several other nations, surpassed the United States in the last few decades here, okay? And so, so you have this, and then all of these other things, right? Costa Rica used to have a life expectancy in the 50s, but then it has climbed up, or is it 60s? I don't know. And so all of these other things. And so I think by kind of arranging the order of countries based on a numeric value, it does make it a little bit easier to try to decipher some of these things. Okay, so this would be Haiti, this would be Bolivia, Trinidad and Tobago, Honduras, Guatemala, Peru, kind of going up the line there. So we have that. Okay, let me give you your last 2 view quiz answers. Last 2 are D as in dog and A as in apple. D as in dog, A as in apple for your last 2 view quiz answers. I've got a few more things. This one, I'm just doing the sum of the population. So if you think about population, I don't know if it makes sense to talk about the mean of different country populations. Like, is it useful to calculate the average, the mean population of, say, these different nations? I'm not sure, but maybe the sum total. How's the total population of the world changed? And again, I'm highly suspect because here it says total population in 2007 is around 6.2 billion, and I think could have sworn it was higher than that in 2007, but you can see how it has grown. If I group by year, we can say, okay, so here I filtered to just the year 2007. It wouldn't quite make sense to do the sum across all time, right? Because we would be counting people multiple times. So I just said group by year and then calculate the sum or the total population in each year. That makes a little bit more sense, and we can kind of create a plot and we can see how the population of the world has been growing. I can also group by continent and year, and we can see how each of the populations of different continents have been growing, right? So Asia has been growing steadily. The Americas and Africa's population have been growing steadily. Europe's population has been growing at a much slower rate. Oceania's population, well, it was pretty small to begin with, but it also its growth has been fairly slow comparatively as well. So this is just some plots to look at. But please do take a look at the RMD files and familiarize yourself with these kind of group by and summarize, and you'll get some exercises in your homework as well. All right, that's what I've got planned for today. We'll see you all on Wednesday.
Have you assigned